Okay, more consequences. Again, we're talking about the mean value theorem here. Just a reminder, in case there's been a break in between that you're watching videos, the mean value theorem says that f of x is continuous on some closed interval and differentiable on the same but open interval. Then there is some point in the interval where the instantaneous rate of change of the function at that point equals the average rate of change across the whole interval. So let's take a look at consequence number 1, which says that if a function has a derivative of 0, the function is constant. Now, you can graphically probably already see this. We've talked about this in our classes. If you've got y is equal to some constant value, it has a slope of 0. It's pretty obvious. But let's see what the mean value theorem says. The mean value theorem says that f prime of some point in the interval equals the average rate of change over the interval, and we'll just say that the interval is some 2 points, x2 and x1. We're claiming that if the derivative is equal to 0, so we're going to write this as 0 equals f of x, whoops, still lasering, is equal to f of x2 minus f of x1 over x2 minus x1. But the only way this can be true is if f of x2 is, minus f of x1 is equal to 0, which means that the value of the function at x2 must be equal to the value of the function at x1, which means that the function is a constant value. So we can conclude if f of x equals some constant, then the derivative of that function is equal to 0. All right, let's look at a second possibility. And this one is going to be super interesting down the road. Functions with the same derivative differ by a constant. So let's think about what that means. If I've got a function that has a slope of 2, and I have some other function with a slope of 2, then the only difference between these functions will be the constant that separates them. And we're about to prove this. So let's start with f prime of x equals g prime of x. We got two functions. And we're in some interval. And we are going to prove that f of x must equal g of x plus some constant value. So let's define a new function. H of x equals f of x minus g of x. So here we go. H prime of x equals f prime of x minus g prime of x. We know this is true because the sum rule of, or difference rule of derivatives. We also know that since these derivatives are equal, that must be equal to 0. Now, from number 1 that we did just a minute ago, this tells us that h, of x is equal to some constant. The only way it can have a derivative of 0 is if it is a constant function, which means that f prime of x minus g prime of x, excuse me, I misspoke there, which means going back to here, that f of x minus g of x is equal to some constant, and therefore adding g of x to both sides of the equation, I get that f of x must be equal to g of x plus some constant value. So let's do an example. And our example will be if f of x equals x squared, we know then f prime of x equals 2x. If g prime of x, this isn't really an example so much as it is an illustration. If g prime of x equals 2x, then g of x equals x squared plus some constant. Now, let's look at an example. Example 7. Let's see. F prime of x equals sine of x. It passes through the point 0, 2. Find f of x. Well, if we know f prime of x equals sine of x, we know that f of x must be negative cosine. We can sort of think about this, say, well, the derivative of cosine is negative sine, so we're going to have to put a negative in front in order to get positive sine. But the previous proof that we just did says that this has to be plus some constant. So f of x is 2, tells us that x is 0. Cosine of 0 is equal to 1, which tells us that 2 is equal to negative 1 plus our constant. Therefore, our constant must be equal to 3, which means that this particular function, f of x equals negative cosine x plus 3. This has a derivative of sine and goes through the point 0, 2. All right, my students, go ahead and do exercise 35 in the book, and we'll be back with the final, or perhaps the penultimate video, which we'll talk about something called an antiderivative. Thanks for watching. Hope you learned something.